Yeah. Hi, everyone. I'm Shaya from NVIDIA. So I'm working as a deep learning scientist. And our team is mostly working on post-training reasoning model for finance using Nemotron model, LLM model for NVIDIA. Today, I'm going to talk about general goal of our team and what's the challenges we are facing, going through an examples to show the challenges specifically, and finally showing our result and impact on the industry. About the goal, so our goal is basically sharing an open source model that is doing the finance reasoning so everyone can use it. But it's not just sharing a checkpoint so everyone can load it and run the model, but we want to share the whole pipeline. We want to share our data open so everyone can use our data. Not only that, they can generate the data using our pipeline, using our recipe, our model, and using our environment and pipeline. So basically, we want to share all orchestra that how we are going through this process. But before that, let's go to an example and show why this is challenging, why the finance is the issue, and we are focusing on that. So just the big picture that for the finance model to answer a finance question, it should go through multi-turn reasoning. So it's just basically calling multiple tools, doing the web search, retrieving the different filing, SEC filing, and not only retrieving them, it's the long document, it's the complex document, different structure, unstructured data, structured data. Model should understand all these documents, and not only understand that, it should do the financial math on those documents, and at the end, cite what part of this document was helpful to answer the question. So to clarify it, let's go through an example. So let's say it's calculate the inventory turnover for US steel in 2024. So model to answer this question should know that what's the turnover formula and how to calculate that. Not only that, what kind of the filing, what kind of the form it needs to be called from which tool, from web, from SEC, and when it's calling, do the extraction, understanding all those documents, and calculate the formula as you are seeing at the bottom of this slide. And I guess the last step is cite which part of this document was helpful for the model. So we can say the answer is based on evidence, and we can confirm this is the correct one or not. But let's see how the models currently are doing on this benchmark. So we look at one of the famous benchmarks that has been recently released on finance, and this is the result. The best closed model is approximately 64%, and open source model performance is only 60%. They recently actually released a little more complicated finance benchmark, and the best performance currently is only for 58%. So you can see how much gap we have to fill in. To show our contribution, to summarize, I summarize it in 4 different pillars. We have done 4 main contributions. First is sharing through SCG pipeline, document-based SCG, template-based SCG. We shared our data publicly. We have more than 1 million data that you can access it right now. We trained some models using our own data based on our pipeline, using SFT recipe, RL recipe, and we saw a great improvement on those model performance. Our pipeline also supporting RL fine-tuning using tool call, and all in one pipeline. Not only that, we already have 2 customers, finance institute, that of course the security is important for them because they are using finance data. But they can use our pipeline without accessing to the internet, so they don't need to be worried about the security. And it's already enterprise ready, so you can use our pipeline. So to show that how improvement we made through this pipeline and based on the data we generate, you can see after fine-tuning Cohen models or Nemotron model, we have seen at about 11% on Cohen model and 7% on Nemotron model performance. Not only that, without losing any accuracy, we reached 25% less token usage, which less token, less cost, better life. So how we have done that? We have done all of this through one pipeline orchestrated under NVFlow. You can do all the synthetic data generation, model fine-tuning, evaluation, and oral training only on one pipeline. And not only that, we made a big important decision in our pipeline, having the shared single environment. And what does that mean? It means all the synthetic data generation, SFT tuning, oral tuning, all of them is just using the same tools, same format, so no need for the worry about being consistent. All in all, we invite you to collaborate with us. Our code data, all of them is shared publicly, so you can use it, and feel free to reach out to us for more collaboration. Yeah, thank you for your time.